we're now going to really solidify our understanding of relationships between lines and being able to determine those relationships. Something that we've looked at for sure, but there's some more fine details that we want to explore here. So first of all, whenever you have two lines in the coordinate plane that have a relationship somewhat like the following, where the slopes are the same as one another, but they have different y-intercepts, then we can classify the relationship between them as being parallel, right? So parallel lines are never going to cross each other and always run the same direction as one another. Now, it's really important that we understand that there are other cases where lines could have the same slope as one another. So if I have this red line per se and then this pink line, it turns out that the red line and pink line actually do have the same slope as one another, but also they have the same y-intercept. And when that's the case, of course they're the same line, but we can't call them parallel because parallel requires that they never cross. And here these lines are actually crossing everywhere. They share every point in common. And so what we call this is we call this relationship here coinciding lines. So the lines coincide with one another when they are exactly the same line. So those are the two cases where lines have the same slope. So the only other possibility then would be to look at cases where lines have different slopes. So anytime two lines have different slopes, they are just going to cross one another. And by crossing, we can just say that they intersect in just exactly one point. And then there's just a very special case of intersecting, and that's when they meet at a 90-degree angle. So whenever two lines do meet at a 90-degree angle, we call that relationship between the lines to be perpendicular. And perpendicular really only happens when the lines have opposite reciprocal slopes. So for example, if you had a line that went down 4 and then over 3, so it had like a negative 4/3 slope, and then you had another line that went up 3 and over 4, kind of like that line right there, then they're going to be perpendicular and intersect at a 90-degree angle. So a lot of what I just summarized right there can be kind of copied down into this table for the most part. So you'll see that for parallel lines, really you need to have the slopes be the same, but then have the y-intercepts be different. Whereas for coinciding lines, lines that are the same line as each other, of course the slopes are going to be the same as one another, as well as the y-intercepts are going to be different. And then anytime lines are intersecting but at not a 90-degree angle, then you need to have the slopes be different but not be opposite reciprocal slopes. Whereas if they're perpendicular, then you'll want to look for opposite reciprocal slopes. Whenever you have like horizontal and vertical lines, there's kind of an exception there because really any horizontal and vertical lines, right, are going to be perpendicular. But yeah. So kind of moving this down to some examples here, we are now asked to determine the relationship between these particular lines. And so when you do so, you really have to prove so. And so to know this, you really have to compare the slopes of the lines to determine these particular relationships. So right here, it appears that the lines are running in the same direction. So it seems like they might be parallel. So you want to check to be sure with the slopes. And so if you find the slope of the red line right here, it appears that it rises 3 and runs 4. So you have a slope there of 3/4. And then if you check the blue line, you've got, let's see, got a point there, as well as there, as well as there. So it looks like you've got a rise of 4 and a run of 5. So the slope would be 4/5. So it turns out that 3/4 and 4/5 are not the same number, because one's 0.75, the other's 0.8, and that's 5/100ths difference. And so therefore we can say that the red line and blue line are actually not parallel to one another. So we can cross it out. Of course they're not perpendicular because they're not opposite reciprocals. They're not coinciding because they're not the same lines. So it's really just kind of a neither. I think the best way to say this is that these lines intersect at a non-right angle. They intersect at exactly one point, but that'd be kind of the most specific way we can classify that relationship. Here you're given some coordinates through which lines pass, so you want to find the slope. So with line 1, if we do 4 minus negative 1, and then 0 minus 3, we get a slope of 5 over negative 3. And then for line 2, if we do 8 minus 2, and then negative 2 minus negative 12, we get 6 over positive 10, which reduces down to 3/5. And so then if you compare that slope with that slope, they're reciprocated, because you got 5 and 3, and then 3 and 5, and then also one's negative, one's positive. So they are opposite reciprocals. And what that tells you then is that they're actually going to intersect at a 90-degree angle and be perpendicular. So we can say that line 1 and line 2 there are perpendicular. Working off of some equations here, you can see that y equals negative 5x plus 4 and x equals negative 5y plus 4. So you can tell from this, because y is solved for alone, that the slope is going to be negative 5. But from this right here, x is alone, and so we don't know what the slope is unless it's solved for y, so you're going to have to solve it for y. So if I first subtract 4 from both sides, then you get x minus 4 is equal to negative 5, and then you can divide by negative 5 to give you negative 1/5 x plus 4/5, which equals y. Then you can go ahead and compare that equation with that equation, knowing that the slope there is negative 5, and then the slope here would be negative 1/5. So if you compare those slopes, they are reciprocated, but they're both negatives, and so they are not opposite reciprocals. So we can rule out being perpendicular. So just since the slopes are different, then we can just say that these lines are really just going to intersect at a non-90-degree angle or a non-right angle, similar to the example that we had first up over there. And then over here, same sort of scenario. We've got equations to work off of. Clearly here the slope is negative 1/2 because it's in slope-intercept form. You're going to have to solve the other equation though, because it's in standard form. So if you subtract 2x from both sides and then you divide by negative 4, you end up getting this equation here. And then when you compare the slopes, one's negative 1/2 and one's positive 1/2. So they're opposites, but they're not reciprocal. So it's just that the slopes are different. So again, these lines are just going to be intersecting at a non-right angle. They just meet at exactly one point in that particular scenario. And here, with these equations, let's solve the first one. So if you subtract 2x, you get that, and divide by negative 8, you get 1/4 x plus 2. And then for the other equation, you can really just subtract 4x and then y is alone. So you get negative 4x minus 2. It does turn out that 1/4 is the slope there, and negative 4, those are reciprocals and also opposite in nature. So it does turn out that those lines would be perpendicular to one another in that particular case, because you got the 90-degree angles going on there. And then here, if we add 3x, and then divide by 9, we get 1/3 x plus 4. And then this equation right there actually is solved for y alone, because y is alone on the right side. And the slope there would be 1/3. So they both have the same slopes of 1/3, but also that y-intercept is 4 and that y-intercept is 4. So it turns out the equation is actually going to be the same lines. So we can't say parallel. It turns out that these two lines are actually coinciding because they're exactly the same equations as one another.